Okay, we've had a look at how to scale vectors and how to add vectors. Now we're going to look at some problems just to practice the skills that we developed. So we have this problem that given the vectors u is equal to 2 times the unit vector I plus 4 times the unit vector j, and v is equal to 4 times the unit vector I plus 3 times the unit vector j, compute the following. We have u plus v, the magnitude of u plus v, 2 times u, and the magnitude of 3u plus 2v. So we begin with the simple vector addition. We have the vector u, which is equal to 2 times I hat plus 4 times j hat. Next we have our vector v, and that vector is equal to 4 times I hat plus 3 times j hat. Okay, fantastic. And we now add these two together. So we add the 2 and the 4 to get the x component of u plus v. And that is 6 times I hat. And then next we add 4 and 3 to get the y component. And that's 7 times j hat. Wonderful result. But now we want to find the magnitude of this vector. And we know that the magnitude of a vector squared is equal to the sum of each component squared. So we take our first component, which is 6i, so that is 6 squared. And then we have our second component, which is 7 squared. That's 36 plus 49, which is 85. So u plus v, and the magnitude of that squared, is equal to 85. So the magnitude of u plus v is equal to the square root of 85. Okay, quite straightforward. And the next one is also quite straightforward. We have our vector u, and we multiply that by 2. So we have 2 times u, or that is equal to 2 times, open the brackets, 2 times I hat plus 4 times j hat. Now all we need to do is figure out what 2u is. We multiply that out, so that's 2 times 2, and that's 4 times I hat. And then the next one is 2 times 4, so that is 8 times j hat. And that gives us our vector 2u. Finally, we have this problem which is designed to consolidate these two concepts of adding and scaling vectors. And we start off here by just figuring out what 3u is equal to. So we have 3 times u, and that is equal to 3 brackets, and we have 2 times I hat plus 4 times j hat. Okay, and we just multiply that out, so we have 6 times I hat and 12 times j hat. Okay, so that is 3u. Next, we want to figure out what 2 times v is. Well, we have our vector v, and we have this little 2, so we stick the 2, open some brackets, we take the first component of v, which is 4 times I hat, and then we take the second component of v, which is equal to 3 times j hat, and we perform that same multiplication. We have 2 times 4, so that is 8 times I hat, and we have 2 times 3, and that is, of course, 6 times j hat. So these are our vectors we are interested in. But now we add them, so we have that 6i and 8i there, so that becomes 14 times I hat. And then next we have 12 and 6, so we have 18 times j hat. So this is our vector 3 times u plus 2 times v. But we want to find the magnitude of that, and we know that the magnitude squared is going to be equal to the sum of the components squared. So this then given by 14 squared plus 18 squared. And I will peek at the calculator and know that this is 520. And that results in 3u plus 2v, and the magnitude of that being root 520. That is roughly 22 2, I believe. Okay, and that was it. Thank you very much, and until next time.